So here we're looking at integrating 1 over x. If we try and integrate 1 over x, we'd try and bring the x up to the top line so we can integrate it and make it x to the negative 1. But if we try and do that and then integrate it, we end up with x to the power of 0 over 0 if we're raising it by 1 and dividing by the new power, which we know is impossible because we cannot divide anything by 0 because it's undefined. So we need to think about what might differentiate to get 1 over x. And if we look on the formula sheet, we'll find that the answer is ln of x. So the integral of 1 over x with respect to x is ln of x plus c. So we'll take a look at a couple of examples. So here we're trying to integrate 1 over 3x. What I'd do first is probably take the third out the front. It is just a constant and the constant just stays there. So now it becomes a third times the integral of 1 over x. Now we know that 1 over x integrates to get ln of x. So the answer is a third ln of x plus c. Here we're integrating 5 over 8 minus 3x. A little bit more complicated because the 8 minus 3x is on the bottom. However, we know that it's x to the power of 1, so somehow there's going to be a ln of x in my answer. If we look at the what's on the bottom and we differentiate that, we end up with minus 3. So that's what we're going to end up dividing by. So first of all, we pull the 5 out the front and we end up with 1 over 8 minus 3x. And this is where the divide by negative 3 comes from. So now we go 1 over negative 3 times the 5 from before, and it becomes ln of 8 minus 3x plus c. And all of the ln ones or over x ones will follow this pattern. So if we can simplify that, that becomes negative 5 thirds ln 8 minus 3x plus c.